So we're here standing in front of the wave basin, and at the moment we are running tests on infrastructure that can grow seaweed in the ocean. And that project is important because we are trying to understand the processes between ocean waves and the seaweed aquaculture, trying to better understand what the waves do with the aquaculture gear and vice versa.
The program is called Ngā Punga or Te Moana, which is Maori is anchoring anchors in the sea. So it's about trying to do something that's permanently beneficial to everybody in the future. So this project aims to achieve an understanding of the different systems that we can use to grow shellfish and seaweed in exposed oceans. It extends right from understanding the cultural importance to Maori in New Zealand, right the way through to the structural designs, through a lot of the technology, and ultimately to get things out into the open ocean or into exposed ocean that will be able to grow the seaweeds and shellfish and de-risk it for industry.
One of the most interesting parts for me as an engineer is, on the one hand, of course, modeling and how the fluid dynamics act on these structures. But even interesting and even more is the biological part, because we learn from the interdiscipline parts with the other colleagues how the structure behaves, what they like. Do they like water depth, sunlight, how much nutrition do they need? And these are new boundary conditions for us from the engineering point of view, which must be implemented in the models as well. It's all worthless if the aquaculture is not growing in the end.
The impact for sustainable food production is that we are not producing fish. We are producing a so-called LTA species, low trophic aquaculture. The nutrients are taken up by the seaweed in the water column, and the plankton is filter fed by the mussels. So we are not feeding anything, and we just have these mussels and oysters and seaweed into the open ocean. So we are independent from this food security perspective from imports from other countries.
And I think it goes past food production. We're also looking at the possibility of nutraceuticals, perhaps pharmaceuticals, and also alternatives to oil and things like that. So can we produce compounds that can be used as alternatives? This project is not just trying to produce a structure to grow seaweed or shellfish. This is about understanding the complexity behind how these structures operate under different sea conditions. And it's also, what we're looking at is to try and identify what the seaweed needs and provide for the seaweed, rather than just trying to build a structure and putting seaweed on it. In the case of seaweed, the same for the shellfish. So it's about understanding, not just knowing. We need to understand from academic right through to the practical aspects of that industry require.
This week we are testing the prototype, which will be installed later in a smaller scale, in a 1 to 20 scale, in the wave basin behind us. And there we are looking, is the overall system that we are investigating working like we are expecting it?
Because not everything normally goes right in the first try. We have here the very unique situation that we simply can drain the water. We change something in the structure, put the water back into the wave basin and test again. And we do it as long as necessary to come up with a very optimized system. And this is just happening very quickly because we can play around, we can test different things, optimize on the run, and this is a unique way in optimizing an offshore structure.
It's not something that's been done anywhere else in the world. People do sectors or segments of it, but to actually have this from start to finish, from start of innovation and thinking, right the way through the computer modeling, wave-based modeling, and putting it out, very, very few people do this in aquaculture. And so I think this will advance the aquaculture significantly, de-risk it, and provide us with a lot more prospects in the future.